because the whole top half circle is shifted, and y is going from 0 up to this curve. So that is the region we want to integrate over. To do that is by taking this equation right here.
Converting to polar coordinates.
Yes, convert it to polar coordinates. So if we write this in terms of polar coordinates, we get r sine theta is equal to the square root of 1 minus r cosine theta minus 1 squared. So we'd like to use this to try to get a handle on, so we want to describe this curve using what's called a polar equation. So this is our goal. It has this form. R is some function of theta. Because then what we can do is we can choose an appropriate interval for theta for our integral, and then this function will give us our limits of integration for r. So we need to take this equation and somehow boil it down to this form, if we can. So we'll square both sides. We get 1 minus r cosine theta minus 1 squared. So we get 1 minus r squared cosine squared theta minus 2r cosine theta plus 1. The 1's will cancel out. So now we have minus r squared cosine squared theta plus 2r cosine theta. But that's equal to r squared sine squared theta. So what can we do with this to simplify it? Or looked at another way, we can take this term, let's just move it to the other side. Now we have r squared sine squared theta plus cosine squared theta, which is equal to 1. And that is equal to 2r cosine theta. So now we have r squared equals 2r cosine theta. We cancel out a factor of r on each side. So we get r is 2 cosine theta. So this is a polar equation that describes this same curve. We just translate it into polar coordinates. Now, we're almost ready to write down our integral just for setup. We're not going to, I don't think we'll have time to do it, but that's okay. Okay, so what we need are limits in terms of r and theta. So our integrand is the square root of x squared plus y squared. Well, that's just r. And then don't forget the r, dr, d theta. Okay. So the limits in terms of r are going to be starting from r equals 0 out to where this curve is. R equals 2 cosine theta. So those are our inner limits. 0 to cosine theta. What would the limits in theta be, though? Like, for instance, when theta equals 0, what's r? Well, it'll be from 0 to pi over 2. Yeah, so when theta equals 0, r is 2. You're out here. Then r keeps decreasing because it's cosine theta until you get all the way to theta equals pi over 2, where you're back at the origin. So the limits are from 0 to pi over 2 in theta. So if we draw the rays, theta equals 0 and theta equal pi over 2, that contains the entire region that we're integrating over. And so r goes from the origin out to this curve for each theta between 0 and pi over 2, but that r is steadily decreasing. Right. So now we would be ready to integrate, and let's see, what do I have for time? Okay. I have 4 minutes, so nobody start racing for the door yet. It looks like it's going to be really simple from this point on, but let's be careful about that. So we have 0 to pi over 2, 0 to 2 cosine theta, r squared dr d theta. All right, so and I differentiate this with respect to r, and we get r cubed over 3 evaluated at 0 and 2 cosine theta d theta. So we get 0 to pi over 2, 8/3 cosine cubed theta d theta. So now that is what you need to integrate. And who might remember, if this was even covered in 168, hopefully it was, how you integrate that? It's not as bad as a trigonometric substitution, but there is a little something you have to do first. Whenever you have an odd power of sine or cosine, there is a standard technique for that.
Yeah,
I know it's dawning on some of you. So what you do is you break off one cosine. All right, I'll pull out the 8/3. So here we have the cosine. We rewrite this as 1 minus sine squared theta. So now we have cosine theta, which is no problem, minus sine squared theta, cosine theta, d theta. So this part, you just do it directly. This part, yes, a u substitution. U is sine theta. Du is cosine theta, d theta. So then this one can easily be handled too. So I mean, and the main point of the example is how we do the setup. That if you if a region is defined by a curve, y equals a function of x, convert to r is some function of theta to get your r limits. And whatever values of theta you need to do this, that will give you your theta limits as well.